Hi, I'm Bailey, and I love everything biology and chemistry. Have you ever wondered why your food turns brown? Like apples and potatoes. When you leave them out for too long, they get this brown color. Well, I wanted to figure it out, so I found an article by the Institute of Food Science and Technology called Fruit and Vegetables Enzymic Browning to figure out the why it happens. When doing any form of research, your first step should always be to make a list of some open-ended questions that you're looking to answer. My open-ended questions were, what is enzymatic browning? How can it be prevented? And what exactly is happening? Within that article, I also found some additional pieces of information that were important for my exploration into the topic, such as why it happens, how it can be slowed down, and an interesting thing that I never thought of is its effect on the nutritional content. Like, is the color actually impacting the inside, or is it just how it looks on the outside? To start off, what is enzymatic browning? Well, it's basically an oxidation reaction causing many foods to turn brown, such as apples, bananas, potatoes, etc. How can this oxidation process be prevented? Well, in order for the oxidation to stop, the enzyme phenolase must denature, which means to lose its shape. Enzyme's 3D shape is very important. If it loses its shape, it loses its function, because its shape determines its function. Once it denatures, it can't perform its certain task. This can happen by applying heat or adding acids to its environment. What is happening? It starts with inside on the cellular level of these foods. These cells contain phenols as well as the enzyme phenolase. When the food is cut or smashed or in any way exposed to the outside oxygen, it causes the enzyme and the oxygen to go into a chemical reaction, which converts the phenols into melanin, which is what produces the brown color. Melanin is what causes our eyes, our hair, our skin to have a certain darker pigment. Some additional important information that I found from this article was the why it happens. Why do these fruits oxidize? Well, the enzymes are basically a catalyst to speed up the chemical reactions. They're supposed to speed up the ripening process, but when sped up too abruptly will cause the rotting to happen very quickly. So therefore, when it's cut, the phenolase speeds up its decomposition, which also adds to its browning. How can this be slowed down? Possible factors that slow down the oxidation process include lemon juice being added to the food, because lemon juice has a very high level of acid in it, which changes the pH level of the environment. The pH level is very important because certain enzymes like pH levels to be a certain way. If you push it to too high or low of an extreme, it won't want to work efficiently. Besides lemon juice, sugar water acts as a temporary barrier to the surface area. It's not a super chemical occurrence. It's not protecting it severely, but it makes a temporary barrier for the oxygen to enter the substance. The last one was the effect on its nutrient content. And the answer I got from this was that the powerful antioxidant vitamin C, it acts as a barrier to the oxidation to protect the food. It's a much more powerful barrier than the sugar water by a long shot. However, after a long enough time, the vitamin C cannot protect the food any longer, and therefore it loses its value in the food. So that's basically taken out of it, and you're not gaining any vitamin C from eating brown food. If you direct your focus down to the bottom of my exploration, you will see a picture of a banana slice going through oxidation. So it starts off fine, but it's cut, which obviously exposes it to oxygen. But just to emphasize that reason, I also put a cut through it, just adding a little more surface area for this oxygen to enter through. So here on the cellular level, you can see the enzymes, which are these red dots, which are the phenolase, and then these little dots, which are the phenols, and these O2 molecules entering the cut in the banana, causing the enzymes to interact with it and causing the phenols to turn into melanin, which you can see on the outside at the end of this oxidation process, creating this brown color over here. Now let's dive in to what all this planning and research is going to turn into. So I'm conducting an experiment to see what happens to a banana slice when you place it into different environments and how that affects how fast or slow it oxidizes. The independent factor in this experiment is the substance. We're changing the substance in four different ways. One is going to be a highly acidic substance, which is going to be apple cider vinegar. The other one is a very high vitamin C substance, which is going to be cherry juice. The third one is going to be a sugar water mix to put that temporary barrier over the food. And the fourth one is just nothing, just out in the open, absorbing that oxygen. The dependent factor is the browning. We are seeing when we change the substance how that's going to affect its level of oxidization, which is what the browning shows on the outside. The control factor is the banana slice. We're using this throughout the whole experiment. It's going to be the same food in each substance. And the control group is the banana with oxygen, which just shows bare bones what oxidation does, and we'll be able to use that to compare it to what the other substances look like and see if that slowed down the process and how significantly it slowed it down. Something that is important to know for our hypothesis is the pH level between the banana and the apple cider vinegar to see how much of a dramatic change that's going to be making in our pH level. So to find the average pH of the banana, I found the range which was 4.5 to about 5.2. I added those together to get 9.7, divided that by 2, and found 4.85 as its average. I did the same thing with the apple cider vinegar and found the range of 3.3 and 3.5, added that to get 6.8, divided by 2, and got 3.4. As you can see, the average pH of the banana is higher than the average pH of the apple cider vinegar, which means when combined, the vinegar is going to drop the pH level of the banana, making it harder for the enzymes to want to work properly, making the oxidization process less efficient. How are we setting up this experiment? To set it up, you're going to need a few materials. You can find most of these and some alternatives just in your kitchen. You're going to need 4 small dishes deep enough to hold about 3 tablespoons of liquid, a banana, a knife to cut the banana, a timer to keep track of the timeline of the browning process, and 3 tablespoons of each apple cider vinegar sugar water, which should be 2 parts water, 1 part sugar, and cherry juice. So I laid out some vague directions down below. It's basically saying that with the knife, you need to quickly cut the banana slices because you don't want them to oxidize before putting them into their substance. That just can cause a little bit of a human error. Can't prevent that very much, but try to go as fast as you can. You should be dropping them into the dishes that have each of the liquids already in them. Just don't pour them in after putting the banana in because you want them to have the least amount of time in the oxidized environment. So one of each liquid and one of each of the dishes. Then you're going to start a timer for 1 hour. At the half-hour mark, you're going to look at the dishes and see how far along in the oxidation process that each of them are, and put that into a data set on a scale from 1 to 10 and basically see where they are on that track. See how much each of them have oxidized and how has that compared to your hypothesis. You're going to do the same thing after the 1 hour mark, after a full hour, to see how that varied from the half-hour mark, and in the end conclude your data by looking at the oxidation, which is what we're looking for. See how that varies throughout the substances. Before we start the experiment, I wanted to share my hypothesis of what I think the results of the experiment will be. I hypothesize that by adding cherry juice and vinegar to the banana slices, that will slow down the oxidization process the most over the plain oxygen and the sugar water. This is because vinegar is very high in acid and drops the pH level compared to the banana, causing the enzymes to work less efficiently, which will slow down the process. Similarly, the vitamin C in the cherry juice is acting as a barrier over the oxygen, protecting the phenols from turning into melanin, so preventing the oxygen from seeping in. So both the cherry juice banana and the vinegar banana should be working slower than the sugar water banana, which is just a bare bones basic covering, and obviously compared to the oxygen, which has nothing protecting it. After my experiment, I was able to prove my hypothesis that I made earlier. Putting the banana slice in the O2 did cause oxidation, not severely, but for the time frame, it was definitely visible, with a change in the half an hour on a scale about 3 to 10, and then moving to about a 5 to 10. Not severe browning because it was only an hour, but you can see it compared to the sugar water and the vinegar and the cherry juice, how much of a visual difference that made, and kind of explaining in the food world how people are altering our food and why they're changing it and what those substances might be.